Our last conic section is the hyperbola. And just to sum things up with the parabola, we saw that if it's in the form x squared is equal to 4py, then it opened either up or down. If it was in the form y squared is equal to 4px, then it opened either to the left or to the right. And then for the ellipse, we saw that it either had the form x squared over a squared plus y squared over b squared is equal to 1. And this was a ellipse that was stretched left and right because the a squared term is below x squared, so that told us that the x-axis was the major axis. And then the other form was x squared over b squared plus y squared over a squared is equal to 1. And this one was an ellipse that was stretched up and down because the a squared term was under the y term, and that told us that the y-axis was the major axis. And then with a circle is basically a type of an ellipse, except that a and b are equal to each other. And instead of just writing the denominators, we just write x squared plus y squared is equal to whatever the denominators were, which could be some kind of a number, but it was basically r squared, where r was the radius. And then to find the focus of the parabola, the focus was just the point 0p if it opened up and down. And if it opened left and right, the point was p0. With the ellipse, the foci, we had two focuses, which are called foci. The two foci were a distance of c from the center along the major axis. And we used the equation c squared is equal to the bigger a squared minus the smaller b squared. And then finally, with the hyperbola, we're going to see that we have x squared over a squared minus y squared over b squared is equal to 1. And the other form was y squared over a squared minus x squared over b squared is equal to 1. And the difference between the two is this one represented a hyperbola that opened to the left and to the right. So we would see a hyperbola that opened to both to the left and to the right. And then this one is a hyperbola that opens both up and down. And then a few things to point out is that the hyperbola always has a minus sign, while the ellipse always had a plus sign. And then instead of the a squared term always representing the distance of the major axis like we saw with the ellipse, in this case, whichever term is the positive term, that one is the major axis, or in our case, for the hyperbola, we would call it the transverse axis. So if it's x squared over a squared, that means that the x-axis is the transverse axis, and that's the one that has the two vertices and the two foci. And if y squared over a squared is the positive term, then the y-axis is the transverse axis, and it has the two foci and the two vertices. And then to find the foci, we would use the equation c squared is equal to a squared plus b squared. So unlike the ellipse, c squared was the difference of the bigger number minus the smaller number, so a squared minus b squared. But with the hyperbola, it's going to be the sum of a squared and b squared. And unlike the other conic sections, the hyperbola has two asymptotes. So here the asymptotes would be like this. And then down here the asymptotes would look like this. And we'll talk about how to find the equation of the asymptotes once we look at an example. For the hyperbola x squared minus 9y squared plus 9 is equal to 0, find the following and sketch its graph. We want to find the vertices, the foci, the length of the transverse axis, and the asymptotes. So here's our equation. It's not in standard form, so we'll go ahead and put it into standard form. So we have x squared minus 9y squared plus 9 is equal to 0. We're going to minus this 9 from both sides. X squared minus 9y squared is equal to negative 9. And then we want this side to equal to 1. So we're going to divide both sides by negative 9. Which is going to give us negative x squared over 9 plus y squared is equal to 1. And then we always write the positive term in front, so we're going to rewrite this as being y squared minus x squared over 9 is equal to 1. So this is our equation in standard form. And what this tells us is that the transverse axis is going to be the y-axis because the y squared term is the positive term. X squared over 9 is negative, so it's not the transverse axis. So we could go ahead and start sketching this. This equation tells us that the y-axis is the transverse axis, so we're going to expect to see 2 vertices and 2 foci on this axis. And we can find the vertices by seeing the denominator. The denominator is 1 in this case. So a squared is going to equal to 1. So a is 1 because 1 squared is equal to 1. So we're going to have a distance of 1 up here and then also 1 down. And then the b term is going to be under this negative term, and b squared is equal to 9, so that means b is equal to 3 because 3 squared is 9. So we're going to go distance of 1, 2, 3. 1, 2, 3 from the center. And to sketch our parabola, we're going to want to sketch our center box. So we're going to connect these vertices. So these are the 2 vertices here. So we can go ahead and write that our vertices are the points 0, 1 and 0, negative 1. Okay, and then the length of the transverse axis, we could go ahead and answer that as well. So this is our transverse axis, and we went up 1 unit here and we went down 1 unit there. So the total distance is going to be 2 units. So the length of our transverse axis is just 2. For our asymptotes, we're going to just go ahead and sketch them. So the asymptotes are going to go through the corner, through the center, and then through the other corner. Same thing with this one. It's going to go through the corner, through the center, and then through the other corner. And then when we sketch our hyperbola, it's going to go through both vertices, and it's going to go along the asymptote and get closer and closer, but never touch it. And then same thing with the bottom. It's going to go through this vertex. It's going to approach the asymptotes. So this is our sketch. And we want to find the equation for the asymptotes. So we can do that by recognizing that the asymptotes are a line. So it's going to have the form y is equal to mx plus b. Because we know that both asymptotes are intersecting the y-axis at 0 at the center, we can just go ahead and say that b is not going to be in our equation. So our asymptotes are going to have the form y is equal to mx, where m is the slope. So if we notice here that we have 2 points of intersection, we have the center and we have this corner, we can go ahead and say that we went up 1 unit and we went right 3 units. Because a is 1 and b is 3. And the slope is rise over run, so the slope is going to be 1 over 3, because we have rise over run, and then we have our x. So this asymptote is going to have the equation y is equal to 1/3 x, and the other asymptote is going to have the same equation, except it's going to be negative because it's in the other direction. So this one's going to be y is equal to negative 1/3 x. So we could go ahead and state our answer here. Y is equal to plus and minus 1/3 x. And then finally we want to find the foci. And we can go ahead and use our equation c squared is equal to a squared plus b squared. Unlike the ellipse which had c squared is equal to a squared minus b squared, for the hyperbola it's the sum of a squared and b squared. So we can say that c is equal to the square root of a squared plus b squared. We found that our a is equal to 1 because of this term. So 1 squared is 1 plus b squared. This told us that b was equal to 3 because 3 squared is 9. And when we square b, we get 9. So this is 9. So our c is equal to the square root of 10. So this tells us that the two foci are going to be a distance of root 10 from the center. And that's going to be a little bit above 3. So we're going to get 1, 2, 3. So it's going to be somewhere here. That's one focus point. And the other one is right about here. That's the other focus point. And then we can go ahead and state our answer. The two foci have the coordinates 0. And then we have plus and minus the square root of 10. And that's it, we're done. Alright, let's look at one more. Find the equation for the hyperbola with vertices at 0, 2 and 0, negative 2, and asymptotes y is equal to 2x and y is equal to negative 2x. Sketch its graph as well. Let's go ahead and start sketching this. So it tells us that the two vertices are 0, 2 and 0, negative 2. So we have those two vertices, and this tells us that this is going to be the transverse axis because the vertices are always going to be on the transverse axis. We can also look at our asymptotes. One asymptote is y is equal to 2x, and then like we saw in the previous example, we don't have a plus b term because it would just be plus 0 because it intersects the y-axis at 0. But the 2 represents the slope of the asymptote, and we know that slope is rise over run. So if the slope is 2, that's the same thing as 2 over 1, which is the rise over the run. So if we start at the center, our rise is 2, so that makes sense, we're up here, but our run is 1. So we go 1 unit to the right and to the left. So what this tells us is our center box looked like this. A was equal to 2 and B was equal to 1 because we went a distance of 1 here and the distance up here is 2. So we can go ahead and start writing our equation. Because the y-axis is the transverse axis, that's going to be the positive term. So we're going to have y squared over a squared. A is 2, so a squared is going to equal to 4. We have our minus x squared over b squared, which is just going to be 1, is equal to 1. And then we don't need to write x squared over 1. That's the same thing as just x squared. So we actually already found our equation. Our equation is y squared over 4 minus x squared is equal to 1. But now let's go ahead and sketch its graph and also find the foci. We'll go ahead and fill in our asymptotes. Gonna go through the corner, through the center, and then through the other corner. Through the corner, through the center, and then through the other corner. Our hyperbola is going to look like this. It's going to go very close to the asymptotes, but not touch it. And then to find where the two foci lie, we're going to use the equation c squared is equal to a squared plus b squared. We know what a and b are, so we can say that c is equal to the square root of a squared, which is 4 because a is 2, plus 1 because b was 1. And that gives us the square root of 5 is equal to c. So our two foci are going to have the coordinates 0 and then plus and minus the square root of 5. And the foci, once again, are always going to be on the transverse axis. So that's how we know it's going to be somewhere here. And this is going to be their point. This is going to be their 2 points. So one has the point 0 square root of 5, and the other one is 0 negative square root of 5. Okay, this one's for you guys to try out on your own. Pause the video and find the equation for this hyperbola. Otherwise, the answer is going to be revealed in 5 seconds.